Welcome to all. Today topic is chromatic polynomial. It is denoted by f of g comma lambda. It's nothing but the number of different coloring of g from lambda colors. Okay, first one is chromatic polynomial of complete graph with n vertices is denoted by f of kn comma lambda. Is nothing but is equal to lambda into lambda minus 1 and so on, lambda minus n plus 1, and then complement of the complete graph with n vertices is nothing but f of kn bar comma lambda is nothing but lambda power n. Suppose G is a graph with k components. It has the components are g1, g2 and so on, gk. Then the chromatic polynomial is f of g comma lambda is equal to product of chromatic polynomials with respect to the components. This is nothing but f of g1 comma lambda into f of g2 comma lambda and so on, f of gk comma lambda. Okay, chromatic polynomial, it has some properties. Property 1 is nothing but in the chromatic polynomial the coefficients are in alternate sign. Okay, and then second property is if G is a graph with p number of vertices and q number of edges, the coefficient of lambda power p minus 1 in the chromatic polynomial is nothing but minus into minus number of edges, that is minus q. Okay, and then we have another property. Third property is constant term in chromatic polynomial is always 0. Let us take a chromatic polynomial. The constant term is nothing but always 0 in the chromatic polynomial. And then fourth one, if G is connected graph, the coefficient of lambda in the chromatic polynomial is non-zero, not equal to 0. And then fifth property is number of vertices in G is equal to the highest power of the chromatic polynomial. Suppose the chromatic polynomial having highest power 4 means it has 4 number of vertices in that graph. Okay, so we have 5 properties to check the given chromatic polynomial is right or wrong. Okay, we have a problem. First problem is, listen, first problem, a chromatic polynomial is given, that is lambda power 4 minus 3 into lambda cube plus 3 into lambda square. We want to check this type we want to check given polynomial is chromatic polynomial or not. Okay, so the highest power is 4, so it has 4 vertices, and then the coefficient of lambda cube is nothing but number of edges. Okay, so the coefficient of lambda cube here is 3, so it has 3 edges. So we have a graph with 4 vertices and 3 edges. Okay, so it has 2 types. First one is connected and disconnected. First one, we are taking 4 vertices and 3 edges. It is a connected graph. Similarly, we draw a disconnected graph like that. Second one, it has 4 vertices and we have 3 edges. Okay, so first case is connected graph and second case is disconnected graph. Okay, now for a connected graph, it is a tree, you know. Okay, so f of g comma lambda is nothing but lambda into lambda minus 1 to the power n minus 1 is the formula for chromatic formula if it is given G is tree. Okay, so the chromatic polynomial is f of g comma lambda is nothing but lambda into lambda minus 1 to the power 4 minus 1, that is 3. Okay, now expanding this, we have lambda power 4 minus 3 into lambda cube plus 3 into lambda square minus lambda. Okay, which is not equal to the given polynomial. Okay, see, so second case is given it may be a disconnected graph like that. Okay, it has 2 components. One is k3, another one is we are taking k1. Okay, so for k3 we write, already we know that the formula for k3 lambda into lambda minus 1 into lambda minus 2. Okay, and so on. Okay, for k3 we write lambda into lambda minus 1 lambda minus 2. For f of k1 comma lambda is nothing but simply lambda. Now expanding and multiple, we get finally the answer is lambda power 4 minus 3 into lambda cube plus 2 lambda square. So which is also not equal to the given polynomial. So the given polynomial, that is lambda power 4 minus 3 into lambda cube plus 3 lambda square, cannot be the polynomial of any graph. Okay, so second one, we have another problem. See, lambda power 4 plus 3 into lambda cube plus 5 into lambda square minus 1. Okay, here see, look at it is, we want to check it is a chromatic polynomial or not. Okay, look at the constant term. Okay, we have the properties. What are the properties? Okay, the in a chromatic polynomial, the coefficients are in alternate sign, and then the constant term is always 0. We want to check that all the properties are satisfied or not. Okay, see, are in alternate sign, but the constant term is non-zero, so it cannot be a chromatic polynomial of a graph. Okay, thank you.